Hello, everyone, and welcome to Axon's Intro to Event-Driven Microservices webinar. My name is Sarah Tori. I am a product manager here at Axonic and the producer of Exploring Axon podcast. Today, I am joined with my wonderful colleague from our marketing team, Marina. If you have any questions about our upcoming events, please drop them in the chat and she'll be happy to answer those questions. A couple of items before we start the webinar. Please note that this is a fast-track training. The information will come at you pretty quickly, but we do offer some more hands-on trainings, detailed trainings that you can participate in if you're interested. So please let us know and we will connect you with the right people and the right webinars and trainings if you are interested. We do have an event section on our website where you can check out to see when and where we're going to be in person, for instance, for conferences or meetups and things like that. If you'd like to come and meet us in person, we would love to see you. If you or your company is interested in a training, also please do let us know. We do offer those either virtual or in person, so we'd be happy to help you with your projects if you need that as well. And one last item, which is a very important item for us, please give us your feedback at the end of this webinar. I will share a form with you at the end, and you can give us your feedback and let us know how we're doing. This is the best way for us to be able to improve on the material that we offer to you. So with no further ado, let's go ahead and get started. So the agenda for this webinar is going to focus on, firstly, the architectural overviews, such as domain-driven design. Yes, the recording will be shared after the webinar. Yes, absolutely. And yes, please do leave your questions or comments in the chat. I may not be able to answer all of them because it's such a short webinar, but we will try to get to those as best as we can during the webinar. Or if you have more questions at the end, I will also share some resources that you can connect with us. So going back to the agenda, we're going to talk about domain-driven design, command query responsibility separation, event sourcing, and then we will dive a little bit deeper into Axon Framework specifics. We will touch a little bit on Axon Server. However, we do offer Axon Server webinars that are also for free. If you're interested in learning more about Axon Server, it will be covered more in those webinars. So let's go ahead and get started. Before I forget, you will see some code samples at the end, towards the end of this session. If you are not a developer, don't worry about it. If you're not a Java developer, don't worry at all. There are going to be small samples. There will be bite-sized, and I'm sure everybody will be able to go through them without a problem. So let's start by architectural overviews. First of which, we're going to focus on domain-driven design. So domain-driven design was introduced by Eric Evans, I believe in 2003, when his book, same title, Domain-Driven Design, came out, which was based on some of the older patterns such as responsibility-driven design. And it introduced some really great ways to organize projects and systems. So domain-driven design itself revolves around the domain model, making it the center of every application. And you should regard the domain model as the foundation of every DDD-centric application. And what you will notice is that a growth in complexity within the application is accounted for usually by a badly designed domain model. So it is very important to put a lot of emphasis in designing a good model. Now, how are we going to do that? Well, first, let's start by explaining what a domain model actually is. These are the definitions taken straight from Eric Evans's blue book, or the Domain-Driven Design book. And he defines a domain as the sphere of knowledge, influence, or activity. The subject area, basically, to which the user applies a program is the domain of the software. And he describes a model as a system of abstractions that describes select aspects of a domain and can be used to solve problems related to that domain. So the domain could be, for instance, an application to resolve a problem for a music school, for example. And a model within that domain could be booking a lesson model or a payment model or a scheduling application. And we will go through some other examples through this webinar as well. So the domain model contains the concepts of the client's domain that are needed to solve a very specific problem, as I mentioned, such as booking a lesson problem or payment problem or scheduling a lesson, which kind of can go hand in hand with the booking or what have you. And this is not just the description of the software, but the entire problem which needs to be resolved. And the domain model never contains the concepts that the client doesn't care about. So remember, it is a model. Only the selected aspects for the client's problem are necessary to put in this model. So let's look at an example. Let's take this photo of our planet Earth. We're going to call it the world as our domain here. And following this, we can define a model within this domain. If we look at this particular other view of our world, planet Earth, we can notice certain things right away. We can see that the countries are disproportionately sized on this map. For instance, Greenland is a lot larger than what it is in real life. Also, we see that there are rectangles put on the bodies of water. And lastly, we notice that the Americas, the continent Americas, are put at the center of this map. So we already can draw some assumptions here. We can see that this map is trying to solve some particular problems here. For those of you who may know this map, it's called the Mercator projection. And what it tries to resolve is a particular problem in sea travel. It does this by putting emphasis on the oceans through the different sized rectangles. And these rectangles are differently sized to support direct lines of travel over a sphere, and therefore maintaining a constant compass course. So supposedly, if you are going from one area of this map, for instance, if you're going from let's say the east coast of the US on the southern part, and if you're traveling from this point on the map to this other point, reaching Europe, for instance, this is supposed to be the same distance as you would go another, let's say, 3 triangles or rectangles, excuse me. So that's what these rectangles are. They're differently sized, but in reality, they're supposed to project a same kind of difference or distance within the map. So moving forward, we can now look at domain-driven building blocks. So now we can, going forward, define some of these building blocks from a software perspective. Now, when it comes to actually doing DDD, there are several building blocks which are important, and we will be focusing on some of them, such as entities, value objects, repositories, etc. Now, there are other building blocks as well in that book. It's a pretty thick book, so there's a lot of different concepts in there. And I highly recommend you checking it out. Some concepts are a bit outdated because this book is now over 20 years old, but still the gist of it is very, very useful in using our current problems within the software applications and systems. So let's look at entities first. Entities are defined as objects that are not fundamentally defined by their attributes, but rather by a thread of continuity and identity. So continuity points out the attributes of an entity that can change, and identity means that it is uniquely identifiable at all times. Now, I'm guessing a lot of you already have a pretty good understanding of what an entity is through your coding experience. This is just a more formal explanation from the DDD perspective. Value object, on the other hand, has no conceptual identity, but it's fundamentally defined by its attributes and it is immutable. So it's already evident that value object and entity are two different things. Entities are definable by their attributes and so on, but value objects are defined by the state the object has, and because of that, it is immutable. Now, if you want to change the state or have a different field, then you can just recreate a new object. So let's look at another example. Would you say, and you can put this in the chat, and I can tell you there are no right or wrong answers, but would you think that human beings can be defined as entities or value objects? And I will take advantage of this moment to take a sip of my coffee. So do remember that the entity is defined by an identity and a thread of continuity versus value object, which is defined by its attributes. So for the sake of time, I'll go on and explain a little bit more about this example. As I mentioned, there are no right or wrong answers. So you could say that a human being can be defined as an entity. Great. Somebody responded entity. Fantastic. So we could be defined as entities, right? Because we do have a form of identification. Also, we are defined by the thread of continuity. For instance, if I don't wear glasses, I'm still the same person. If I change my hairstyle, I'm still the same person. If you go through various changes throughout your lives, but you're still the same person. And you have a way of identification, right? We all have, let's say, some form of it, either be it a birth certificate or a social security number or another form of identification that identifies you as you. Even if you change your name, you still have a way of identifying. So you could say that human beings are indeed entities. However, just like anything in software, it depends. If we take human beings in this kind of context, we could indeed say that human beings can be value objects as well. Because in everyday life, you could argue that, yes, we are entities as individuals, right? We have continuity as we undergo remarkable changes, but we keep having the same identity, as I explained a moment ago. However, in this example, if I hope nobody works in such a company where you have these little cubicles and you have to work there, but for those of us who have experienced this, it's not a pleasant one. In this case, the company itself, or the job for that matter, doesn't care about the identity of each human being, each individual who sits behind these computers and completes the tasks. It could be anybody. At any which point in time that you decide that you don't want to work in this environment anymore and you want to move on to something else, you can be replaced by somebody else who is willing to work here. So in this case, you could say the identity doesn't matter, the thread of continuity doesn't matter. You just want somebody to sit behind this desk and complete the tasks. So in this case, you could argue that human beings can be value objects. So moving forward, now let's talk about a repository. So a repository is a mechanism which encapsulates storage, retrieval, and search behavior of a collection of objects. Why is a repository an indisputable member of the domain? Well, because the domain and eventually the model within that domain defines how to retrieve the right object from the storage. You don't have to search for the value objects, as you can just create a new one. There is no identity, so you don't have to search an existing version of it. How the repository technically retrieves these objects is not part of the domain, because the business doesn't care how it happens as long as it does happen. So the repository building block is targeted towards retrieval of identified objects like entities, but a bit more specific also towards the aggregate. Now, the aggregate should be described as a group of associated objects which are considered as one unit with regards to external data changes. Internal, for that matter, actually, as well. So, but external reference to this group of objects are restricted to a single member of the aggregate, which is called the aggregate root. And lastly, a set of consistency rules apply within the aggregate's boundary. So really, an aggregate is a group of value objects combined in one thing. If there's a data change, you want to act on the entire aggregate in regards to this change, because maybe several things need to change and the objects within the aggregate, and they need to happen at one go. And that has to be an atomic change from the outside world. So let's look at another example. Would you say a car is an aggregate, for instance, or not? Well, we could say it is, because first of all, car consists of several different parts. You have doors, tires, seats, engine, and so on. Secondly, there is a single point of reference to this car, for example, the vehicle identification number or the license plate. And that can be your aggregate root, right? And lastly, there are consistency rules within the car. For instance, I have to turn the key in the ignition for the car, for the engine to start running, or I'd have to turn the steering wheel to a certain direction for the car to move towards that direction. Now, finally, let's talk about events. An event is a notification of something that has happened inside of the domain. For instance, a flight has been canceled or the text message has been sent. An event describes something which has happened, and this makes it so that it's in the past tense, and it makes it history, right? So because the events are history, they are immutable, which means they cannot change. They're both fundamentally immutable, but also functionally. Event handling is conceptually, therefore, asynchronous, because you just throw the event and anybody within the system that can handle it can take care of this event handling. Now, you don't care how this handling is done by whom, as long as it is done. You don't even care when it's done, as long as it is done. So event sourcing and event handling then can be done asynchronously and is done asynchronously. And we'll talk a little bit more about it as we go on. So that wraps up the section on domain-driven design. Now let's talk about another architectural concept, which is called command query responsibility separation. And let's see how that's done. Now, what command and query responsibility separation, or CQRS, as I will refer to it as we go on, does, it actually separates your domain into two main parts. One part is responsible for dealing with updates or creates or intentions, which are called commands. And the other part provides information or queries, which simply is called the query side of the CQRS. Now let's look at a diagram that we're going to go on and talk about a little bit here. But first, let's talk about how these commands and queries are targeted towards various parts of the application. First, we have the command that's targeted towards the command model only. And the command expresses the intent to trigger an action within the domain. And the intent is important because the model might decide against this operation at some point. Now, secondly, we have the query going to the query model, and the query describes the request for information or state. There's some more building block with which is events, and we will look at that here shortly as well. So doing CQRS allows us to create two dedicated models for two distinct formats of a problem. On this left side here, we have the command model, which is in charge of executing tasks maybe as fast as possible. These tasks are primarily expressed as dedicated forms of operations. And the only data the command model needs is the information required to drive the decisions. All this makes the command model the main point for business logic, because as it decides whether a decision or a task or an operation can be performed. On the other side, we have the query model or projections that are focused on delivering as efficiently as possible. To that end, we would typically denormalize the data because you want the data that's being stored to be as close to the data that is requested. And this brings the notion of denormalized data or table purview, which we will look at here shortly as well. So as I promised, we're going to look at a diagram. When we look at this diagram, we can see that this conceptually is one application because it is connected through that client or the UI. And on one side, you are going to see one thing, which is the command, and on the other side, you will see the queries. Now, command model here shows more complex models and more boxes that are interconnected. And this is done as the command model is driving our decisions, for which the consistency boundary is extended between different entities and value objects, for example. And the notion of aggregates and interconnected objects is shown here as well because the state changes happen here. And you can see that they have different colors. So you can say this one, the purple is one aggregate, red could be another aggregate, for example. Now, on the query model, you will see more loosely coupled models, and this kind of goes back to denormalized data. and distinct boxes that are presented in this part of your diagram. And that's true because we want the data to be stored in a way that we can access it quickly. So in essence, we have made two distinct groups of domain models this way, but still very much part of the same application. The only thing is that we're selecting the only parts that are needed to resolve the issue at hand in our domain on each part of this one application. Now, I did mention something which is consistency boundary, and that kind of refers to something within domain-driven design as well, which is bounded context. You can read more about those if you're interested. We have some blogs and some information on that as well. And of course, it's in the DDD book as well if you want to take a look at it. But moving forward, so there is one important missing part here, which is needed to synchronize the command model with the query model, because they still need to communicate in between one another. And that part, of course, is the events, which we're going to see again on the diagram here shortly. So how they are synchronized is that we now have a command model which drives the decision, right? The state changes, so to speak. And this, the things that are being changed on this side, as I mentioned, should eventually be consistent and visible, basically, on the query model as well. And for this, we can look at three different approaches. One is shared data source, which means you use the same database with persistent views. But this pulls the problem back into the data source layer. So not great. Or you could also use stored procedures on your database. So changes on one table triggers changes on other views and tables. But this also brings back the notion of interconnecting tables, right? Now you're making a lot of connections between tables, and we lose that denormalized data that we like to have because we want to be efficient. And lastly, we can use an event-driven architecture. And as you guessed it, this is the part we're going to talk more about. Which means changes happening on one part are marked by an event, which is used on both ends of that diagram that you just see, which you will see again, which then shows the updates or changes on both sides. So going back to the diagram, events that are published by the decision-making part of the application, which is the command side of your application, can be used to synchronize the changes on both models. Actually, they can update the query model, but they can also update the query side as well. Now, as you may recall from the conceptual description of events, this makes the process asynchronous and therefore eventually consistent. And with that, we've covered the overall construction of CQRS-based applications. But we need to do another explanation, which is the event sourcing part, because we did talk about events and the fact that they're eventually consistent and the fact that they have to update both models within an application. Now, let's talk a little bit more deeply about that. So event sourcing defines a storage method for the command model only, not the query model. It's just for the command model, and that it is a storage method. The command model is stored through means of distinct changes, essentially different events. Now, to retrieve the command model, aka your aggregate, from the repository, you would replay all of the events applied by that aggregate. It's important to note that you would do this against an empty instance of that aggregate type, and we will see that in code example here shortly. Doing this replay activity against an empty instance means that you are recreating, or as we call it, rehydrating the state of that aggregate step by step. So what we're actually doing when we are using event sourcing is that it's not just the query model that changes through events, but also the command model. And that's what I meant, that it updates both sides of the application, the query side and the command side. And I will repeat this information because it is important. And as we go, we will see that as well in code. So we are, again, by doing event sourcing, we are updating the query model through the changes with the events that are published from the command side, but also we're updating the command model as well. And that makes it so that we have a single source of truth, which are the events, which create every model contained within one application. Now, the event store is the key aspect of doing event sourcing because we need to save these events somewhere, right? We did say that this is a storage method. The main focus of the event store is to append events, which means it just adds events to it. There is no update or deletes. And as you may see in some of our blogs or some of our other recordings, we usually don't recommend doing CRUD in event source applications. You can do CRUD in other applications within your microservices, but basically in your core business application, it is important to just focus on the event sourcing if event sourcing is indeed what you need to do. But do keep in mind that you cannot change your events, you can't delete your events, and you can't update your events. So you can create, but you cannot remove, update, or delete. So this makes sense because the events are immutable. And they are the things of the past, their history. And in real life, you cannot change your history, but you can just add to it as you go day by day. You add to your history, but you can't, of course, change things within your history. Now, there are ways that you could change your events in extreme cases. For instance, if you're dealing with sensitive data or if you're dealing with a different let's say, law that is put in place, and that makes you want to go back and change some of your events. Let's say having to do with GDPR or HIPAA or something like that. There are ways that you can modify those events, which unfortunately I will not be able to share here in this webinar, but we do offer those within Axon Server. It's called Event Transformation, which I highly recommend you read about it. We do have some resources on our website that you can learn more about that as well. So it's not as inflexible, but of course you don't want to change your events on a regular basis. Let's say if you want to change an email, you go back and change your events. That's not something you want to do. But in some cases that have to do with data privacy or sensitive data, you do have the options to modify those events as needed. Now, with that, with all of that said, Axon Server, for example, is a purpose-built event store. So it really helps with your event sourcing activities because it really provides a nice platform for you to be able to not only store your events, but also keep track of how your commands and query handlers are functioning. You get a lot of information through that as well. As I mentioned, I can't really go deeper into Axon Server in this webinar, but we do offer free webinars that talk more about Axon Server as well. So Axon Framework also supports the usage of relational database through JPA and JDBC or other forms of databases such as MongoDB, non-relational databases. So there are some downsides in using no relational databases or even relational databases that are used for generic purposes. In short, it's because these databases are in charge of doing a whole set of other things than just storing the events. And so therefore, using a purpose-built event store, such as Axon Server in our case, can be a better route for you to go. It really depends on your needs and what you're trying to achieve within your business core problems that you're trying to solve, basically. But as I mentioned, we do have a lot of resources on the website, or if you have any questions now, you can ask them, and myself or Marina would be able to answer those questions. So we use events to create our query models, as I mentioned a few minutes ago, but also to recreate our command model. And that means we will have a single source of truth. Conceptually, this is great, but there are also business reasons why this is so valuable. Now, by following this concept, you can reuse the events in the event store for alternative solutions in the future. So you'll have less information loss overall. But it also provides you with an audit log of how something came to be exactly. This is great because you're not only storing the state of something, but how you arrive to that state, which is very important as well. And lastly, as events represent deltas, you therefore increase performance because events are the only part of your data that you are storing. And you can even cache results to prevent big reads at times. So it really helps with your efficiency and speed. Now let's look at an example. In this example on the left side, you can see a regular state stored approach, as opposed to on the other side where you see an events sourced approach. So on the left, you see that you have an order with some information, but you don't have a whole lot of information and you don't know how you got to the final state of this order. So for instance, you can see that there's an ID number, there's an item, which is a chair for a certain amount, and the final status tells you that the return shipment was received. But we don't have any other information in between, right? Now, if you look on the other side, you see that you get a lot more information in much smaller pieces. So you can see that an order was created, an ID number was given to that order. Items were added to the shopping cart. At the beginning, there were two chairs that were added. One was removed for whatever reason. The order was confirmed and shipped and received by the client. And the order was then later on canceled by the user and the return shipment was received. So, of course, you can see that the pieces of information that you're storing in your event store are much smaller on the right side. So you can see that it's going to help with cases that if you want to retrieve an information, it comes back a lot faster because that information is a lot smaller to read, right? So that part is extremely powerful and important. But you can also see the business value here. You can go back to your log of information and see exactly what happened with that one particular order. How did we come to this final stage, which is return shipment received? On the left side, of course, you don't see that detail. On the right side, you can see that, hey, there were two chairs selected at the beginning. One of them was removed. Now, if you really wanted to, you can go back and do some monitoring and put some metrics in there and see how often does this happen, for example. How often do people put two or more items in their cart and then remove some of them, and why that is? Is it maybe just a dysfunctionality on the UI side that somehow creates two chairs right off the bat? If somebody clicks on one chair and then the user has to go to the cart and remove one of them, or was it because the user is really interested in more than one chair, but perhaps the price at the end comes out too expensive, or the shipment is too large, or maybe there's a shipping cost that changes with shipping one chair versus two chairs that makes it undesirable for people to have this. So you can see that this is just a simple example of it, but you can see that you can go back and on the business side, on decision-making side of things, you can make a lot of changes and view and adjust a lot of your business decisions as well, which is extremely powerful and important here as well. Now, great. We talked a lot about some practical things and also some really structural and patterns within your software systems. This almost brings us to the end of the architectural overview part of today. So if we combine our knowledge of CQRS, DDD, event-driven architecture, and event sourcing on this slide, we can see that our building blocks or the messages are shown here. We can already use our idea of CQRS coming back to play here with a client or UI side, sending commands and queries to two distinct parts of the same application. And there are events being published by the command model, and that we have on the upper right side here. And the command model consists of the number of aggregates, entities, and value objects. Now, then you have here the repository building block that we talked about as the abstraction layer to retrieve our command model. On top of that, we are using event sourcing right here. Therefore, the repository's technical approach is to follow this paradigm. And Axon Server specifics lie in this section as well. Where is the storage? Right here. So this brings us to the projection side of our application on the bottom side in the domain model, as you can see, of our event handling side. Now, This is interesting to see because the both sides on the command side and the projection side have very similar things in the domain model, right? They have aggregates, entities, and value objects, and so on. And this is an example of how a model can change so that it only contains the selected aspects for the problem at hand. The deviation makes sense because the model up top is for commands, and on the bottom side is for the queries. Now, although you see that there are aggregates, entities, and value objects, and it may seem identical, but they are not. They only contain the aspects that they need to deal with in each model. So the aggregates on the command side are not the same as the query side. You will have different aggregates, for instance, on the query side, or values, or value objects, or entities, and so on. Now, this leaves me with the final concept that I'd like to discuss, which is the great big why. Why is it that we're going through all of this trouble and you decided to join me for this webinar? So why would we do all of this? There's a lot of planning ahead that seems to need to happen. There's a lot of discussions within each team that needs to happen. So why are we doing this? So let's say you have a greenfield project in mind that's going to generate you a lot of money in business. And that's fantastic. So you want to get started because you know the values of, say, microservices. You really want to be able to take advantage of using microservices because you know that you're going to want to expand your business and expand this application in the future. So you really want to go for microservices or modular systems here, right? So but how do we get there? As I mentioned, there's a lot of planning that needs to go along with it, and you may get there just fine. But as we know, a lot of times, if a project starts, you want to get to the next step, which is making money, right? Because that's the most common objective of every business. You want to be able to generate revenue, or you want to be able to get investors. So how do we get there? You have to be able to show results. Do we want to then put months and months of planning and designing architectural concepts and the system and possibly get there, which is great. But a lot of times we may not get there and we may burn out in the process and end up in Death Valley instead of ending up with a nice, beautifully designed microservices system. We end up with, let's call it a nicely distributed balls of mud. So of course, we don't want to get there. We want to get to the other one, nicely designed microservices. So how do we do that, though? There's a way that we at Axonic recommend it to be done, and we call this evolutionary microservices approach. So what that means is that when you are planning on getting to this beautiful microservices way, you can create a well-structured monolith to begin with clear separation of concerns in distinct components that are beautifully done in different colors. Turns out it's a lot easier to do it in a slide deck than in real world. So, but let's take this. You can have distinct components, right, in different modules, for instance, within the same monolith. Now, as the needs arise, you can then decide if you want to take one of these components out of your monolith and make it into its own microservice. And maybe you will need to take one of those components and replicate it, right? You can do that as well. You can take it out of your monolith, put it in its microservices, and have, let's say, 2 instances of it, or replicate it in another way. So you see that you have a lot of flexibility here. If you start with a well-structured monolith, you can have various modules within that monolith. Once the needs arise, you can decide if you want to take those modules out of that monolithic system or you want to keep it in there. That makes it really easy. And because your modules are communicating amongst one another using the messages, commands, queries, and events, it's really easy because if you're taking it out of that monolith, you just reroute your messages to now your new microservice. So as you can see, there are a lot of benefits that is in there. And later on, you can even decide to go into cloud or serverless, and that makes it possible as well quite easily here also. So there is an easier way to get there and a faster way. You start again with a monolith, we call it well-structured monolith with a nice design on your APIs, and really deciding on where those boundaries are within your domain. How do you want to design your models within that domain? And then you can get started and really reap the benefits of this kind of design with the microservices. And something that makes this happen is called location transparency. Now, location transparency is an old, well-known concept within communication systems. And what it is basically it's a networking process. It's the concept that components should not be aware nor make the assumptions on other components that they interact with on their whereabouts and knowing where they are. The idea behind doing this separation of knowledge, where each component is, makes it so that you can remove or scale up certain portions of your application when required. So like I mentioned before, you can connect your applications and your modules basically through messages. And those messages make it possible for you to, again, move these modules where they need to go quite easily. You just reroute those messages. Now, when both models are in location transparent, meaning that they depend on each other's components, you lose this option because they are coupled to one another. So first you have to decouple them. You have to separate these concerns to be able to get to this wonderful location transparency heaven using the good API design. Now going back to this diagram, we are going to now talk about the upper portion of it, which is the command side, and then later on the query side, and so on. So here you can see the boundaries, first of all, that make it possible to create clearly separate your UI from the command and query sides. And this makes the commands, events, and queries the good API requirement when following the location transparency. And the message buses are the means to just send messages without knowing what piece of application is actually going to deal with this message. And that kind of goes back again to the location transparency notion. And we do have some great blogs on this as well, again, on our website, if you'd like to check those out. Now, let's look at some more Axon Framework specifics. When we talk about all of these CQRS DDD notion, now let's show me the code, right? So let's first focus on command handling and aggregate design through Axon. So here we're going to focus more on the top portion of this diagram, which is the command handling portion. Now let's first start with what a command handler actually is. The concept of command handler is a component which accepts incoming commands. Now, upon receiving these commands, it consults the command model and publishes events. Now, it may also update the command model either directly or through those events. As we already pointed out earlier, the command model only ever contains data which is required to decide whether or not it can execute that command. So in Axon, a command handler manifests itself in an actual component which is subscribed to the command bus to handle specific types of command. The function to actually receive the command messages are annotated with, as you guessed it, @command handler. Now, this command handler annotated function can reside on a singleton component or directly on the command model or your aggregate. In an actual Java function, this would be something that you might see in your code. And this command handling function is subscribed to the command bus, which will handle the join room command in our example. And an example is focusing on a chat room. Welcome to the 90s. So as I mentioned here just a moment ago, you can use the command handler on a singleton component, which could be just a command handling class or a message handler class, or it can be on a command model, which would be your aggregate. So you are not restricted to use aggregates. I want to focus on this because you are going to see a little bit more flexibility here with our next release here in Axon Server and Framework as well. You do have the option of not using aggregates. I just want to put it out there because that notion kind of scares people off right off the bat, thinking, oh my gosh, now I have to have everything prepared within an aggregate and know what needs to go in that aggregate. You do have options not to use the aggregate. So if you just want to use a message handler here, that's fine. If you want to use a command handler class, that's okay too. But moving forward, we're going to look at the aggregate design as well. So from here, as I mentioned, as I promised, we are looking at the aggregate class as well. So here we are on the command side, of course. We're looking at the command model, which is our aggregate here. And this marries the DDD concept of deriving a group of entities with the CQRS concept of dedicated parts handling different operations. And you can see this really distinctly here in code. For example, our aggregate is called chat room. And for configuration simplicity, we will be using Spring in our samples. And here, the aggregate, the add aggregate annotation is actually a Spring stereotype, which notifies the Axon Spring auto configuration to wire up the necessary infrastructure like command handlers and the repository. So after that, you have this aggregate identifier annotated field that points out the identifier of this message, this aggregate. So the single point of reference for this aggregate can be shown from the outside point of view. And this is the sole required annotation on the aggregate. And this is basically your license plate or your vehicle identification number in our car example. Now, this makes the chat room the aggregate root as well. So it contains the external reference towards this aggregate. Then we have the command handling function that we just saw in the previous slide, which states the intent to join a room. As we might recall, the command is the expression of intent to perform some operation. We want to propagate this change through our system with events as we are following an event-driven architecture. To that end, we need to publish an event from within this aggregate's context. For this, the framework provides the aggregate lifecycle apply method, which is the static method that resides here within the aggregate lifecycle. So later on, it can be used for sourcing, for our event sourcing. Now, in code specifically, this function call will publish the room joined event. As you can see, that event is posted in a past tense format. Now, this is how the aggregate, this command model, is event sourced from its own events. To explain this, let's look at the chat room aggregate again, but now we show two different methods. In this sample, we have a command handling constructor to create a chat room. This is therefore the initiation, basically, point of this aggregate. In addition to that, we have an event sourcing handler, which handles the room created event published by the room create room command handler. Now, this separation into distinct methods is required because we are doing this aggregate based on the CQRS model that we talked about, and we are event sourcing it. So that's why you have this event sourcing handler within your aggregate. So hence, the state changes in a command handler are a big no-no here because they will be picked up when replaying your past events. So within our aggregate, you will see and achieve a clear separation of concerns. Command handlers are there to derive the decision-making logic and publish an event to note the decision as being fact. The event sourcing handlers, in turn, are there to adjust the state of the aggregate. So it is important to note that these event sourcing handlers will only handle events from this aggregate instance, meaning no events published by other aggregates. And as mentioned before, it is required for event sourcing, which is what you create with an empty aggregate instance and replay that aggregate's events to recreate the state of your aggregate. And one other thing that I'd like to mention here is that you will see the at event handler annotation coming a little bit later on. But this at event sourcing handler is what you're needed in your command side. The at event handler you will see will be shown on the query side of things. That's a minor difference. Technically, they're not too different from one another, but for better design of your systems, it might be best to use the add event sourcing handlers within your aggregate on the command side and use the add event handler annotation on the query side. And we will see examples of that as well. So we've got our command handling functions. We still need to get the actual command message to our command handling components functions, right? So we are dealing with an aggregate as the command model. We have a single entry point into the aggregate referenced by an identifier. And this identifier should also be present on the command message you send, which is done by annotating a field or function with the add target aggregate identifier. This tells Axon where it can get the identifier, which points to a single point of reference for the command model this operation should occur on. And as you can see, you can also create Kotlin classes for your messages, which makes it much less verbose, which is something I really like for Kotlin. And this will provide a shorter notation here and the option to group several commands in a single line, which is really powerful from Kotlin. So now we've talked a lot about handling and receiving commands, but we also need to route them, right? And publish and dispatch these commands. And there are two ways that you can do that through Axon. One is you can directly do it onto the command bus component, calling the dispatch function, or you can use the command gateway and its send or send and wait functions. And I would suggest using the command gateway because it just gives you some extra handles on how you would want to send your command. And you can do that by non-blocking with returning a completable future or with a callback, or you can use the blocking with or without a timeout. Now let's look at the event handling in the query model. So in this diagram, now we're going to focus on the bottom side of it. Now, what is event handler? It is very similar to the command handler, but of course, with regards to the events. An event handler is a component which handles published events. The event handler can then, for example, create or update projections. It can trigger external activities like sending an email or a text, or it can manage a complex business transaction. And in Axon, this is done by sagas, but we will, of course, not go through those in this session. And it is a different kind of saga than what you might have in mind. But of course, if you're interested in that, again, we do have some resources online. Now, more specifically looking into Axon Framework, an event handler is a component which is subscribed to the event bus to handle a specific type of event. By subscribing, it will receive or pull events from the event bus to handle. Code-wise, this is done by annotating a function with the add event handler annotation, which looks as follows. Here, we have an event handling function for the room created event. Now, putting it more concretely, you could have a Spring Bean with add component. The add event handler annotated function on is called automatically when a room created event is published. Now, hopefully this is pretty straightforward. Now let's discover what actually happens when handling events. And that is, as I mentioned before, it creates or updates query models. As discussed earlier, you would want to optimize the query model to answer the queries as directly as possible for the problem that you have at hand. And the models are focused on data. They are denormalized to map the needed requirements directly. And of course, the model is updated by an event handling component. When setting up your query model, you should consciously optimize them for the requirements of those models. So if, for example, you want to be able to quickly return the results as the query comes in, you would store the views as it's required. So, for example, as a JSON representation. Now, this increases the query performance and flexibility, but you would lose time on updating the views because you would need to do string adjustments for all of them. Now, if you need to efficiently store your data, you would probably not store the views as a JSON string, of course. You would then lose the exemplified performance gain in favor of storage space gain. In short, there are things you can optimize for, and you should think about those based on the requirements that you have at hand and for those specific query models. And the fact that we have decoupled these models and these data tables for in this case as well It will give you flexibility to use them for the exact use case that you have at hand. So, as I mentioned a moment ago, you should normalize your tables to be as optimized as possible for the queries your client will do. Let's say you want to be able to query a complete order and return it immediately instead of having to join the order and the customer tables. In this scenario, you probably wouldn't create tables like this order header table because it's not normalized and would not tailor to our requirements that we have. You could instead optimize for complete data retrieval based on an order ID. So you just focus on that one order ID. In addition to that, the order is intended for the UI. So as you can see in this example, you would just have a table containing an ID or several IDs for that matter, and the complete projections. This is obviously optimized for full data retrieval based on a single identifier. The heavy lifting, so to speak, would now happen when creating this projection, but when queried for, the response can be sent back quickly. And the missing link here that needs to complete this picture, which is the query handling. Now, a query handler in Axon is again very much similar to command and event handlers. Although this time it's about the specific query message and the query response that you want to receive, which are registered to the query bus. Similarly to event handlers, query handlers are functions on singleton components. In code, you would use the @query_handler annotation on a function, and the first parameter will again be the type of message it can handle. And in this case, the return type of the method is very important, and that is your query response. So I'm going to speed up a little bit because we only have a few minutes left. Now, in more detailed example, you can see this class is capable of handling two types of queries. One of them is sum query returning sum response, and the other one is sum list query that returns the list, sum list responses, of course. And this shows that you can have a single result from a given method or several results. And we do have code samples on GitHub that are publicly accessible. If you want to look at those, please check those out on Axon's GitHub. So just like the commands, we need a way to dispatch or publish these queries, and we can do those by using query buses or gateways. And just as we saw with gateways with command handlers, you can use the query gateway. I would recommend it because it does give you some more options as well. So it is important to note that the response is contained in a completable future. In addition to providing the query payload, also details of your query, you specifically want to focus on the response as well. And in this case, you can see that you can get one response back or multiple instances of multiple responses back to you. And we'll see why that is needed. So we have three types of queries. We have point-to-point query, which you ask for a question, receive an answer. You have scatter-gather, which is you ask the same question, but you may receive several different responses depending on what those responses might be. Or you have a subscription query, which is a single destination for an initial response, works similarly to point-to-point at the beginning, but it gives you real-time updates as you go. Now, point-to-point, super easy. You ask for a price, you receive it. Scatter-gather, also easy. You ask for a price. Based on an if statement, you can get a second response, or you may have a special case. For instance, you have a special deal going on with your sales that you want to have a timeline specified for that. And for instance, you can put a time out there that says, hey, this sale starts from tomorrow until the end of next week. That timeout comes at the end of the next week so that you won't get that response beyond that. So you can see that there are a lot of options that scatter-gather brings to you. Now, for the subscription query, you have that same question that's asked for a price of an item. Now here, the updates can be very useful because you can receive those responses coming in. So for instance, you can get the first initial response as $40.49 for the price of that item. And the updates specify the new price for this example. And on the receiving side, you can decide how to deal with these deltas, right? So we likely will take our initial result and sum the deltas with it to end up with the actual price that's needed. Now, looking at code, you can see that there are a lot of similarities. For instance, you have the add query handler for your query handler here for this room message query. This will return the initial result of the subscription query. Additionally, we have now wired a query update emitter in this example, and that is required for you to get those updates sent back to you in real time. Now, the emitter here, as you can see, is calling upon updates of the query model in the message posted event handler. Now, as we synchronize our models through events, the query model is then updated by an event handler. The event handler is in charge of emitting query updates in the scenario because it knows best when the model is updated. Now, to summarize, we did talk a lot about a lot of things, and that can be really overwhelming. But again, this recording will be shared with you after this session, and you can go back to it and check it out. So we did talk a lot about architectural concepts such as domain-driven design, and within that, we talked about the domain model, entities versus value objects, and aggregates, which is another component of domain-driven design. And then we talked about CQRS, which basically separates the concerns of your application into two different parts. One part takes care of the intent. The other part takes care of receiving and retrieving information, which is your query side. And the events then make it possible to be published on the command side to update the query model, but also in instances that you need, it will also update your command model. And for that, we talked about location transparency, which is the notion that your components don't need to know the physical location of other components they communicate with. So that gives you a lot of flexibility to be able to go from a monolithic, well-designed monolithic system with clear API design to be able to go into more modular or microservices systems. We then talked about how you can use these concepts together, marrying the DDD with CQRS using commands, queries, and events, which we use as messages, but also we handle them through various parts of your CQRS application. So command handlers take care of your commands or your intents to be handled through your command model, that they can reside on singleton or your aggregate model components. We did talk a little bit more specifically about aggregates and the annotations within those, as well as command dispatching and the choices that you have there with command buses or gateways. We then talked about the query side of things, which are then dealing with the published events that are coming from the command side to update your query model. We talked about various types of queries, being point-to-point, scatter-gather, or subscription queries, and basically put everything together to make all of these rather abstract conceptual models into more practical ways of looking at them in your business side and also in your code. So this one is actually outdated. We are looking at API World. If you want to come meet us in person in February, in Oakland, California. So for those of you who might be in the area, come see us in Oakland in February. And of course, come visit us for our, it's a little bit early to announce it, but I'm going to do it anyways. The information is on our website, our conference, which happens annually in September. If you want to come see us in late September in the beautiful Amsterdam. Please check our website out for our in-person and virtual events, and do ask us any questions that you might have. We do have various ways for you to contact us through our website. Of course, you can contact us through our contact sheet. You can contact us through Discuss platform with your more code-specific or architectural concept-specific questions that you might have. Check out our academy. We do offer some free courses there to introduce you to some of these concepts. It is self-paced. You have some little quizzes at the end that you can basically see how well your understanding of these concepts are. And of course, you can purchase more courses to dive deeper into that. Again, at the beginning, I mentioned that I do a podcast called Exploring Axon, which has a lot of episodes. I think we're nearing 80 episodes at this point. I've been doing it for 3.5 years now. So a lot of these concepts are covered in detail in those podcasts in that audio format. I did ask everyone to please give us your feedback. So I can share, or Marina, if you can share this this link with everybody in chat, that would be great. And if not, maybe I can come out of this and just share this with you here in the chat area. If you can give us your feedback, we would really appreciate it. So a few minutes over our webinar, at the end of our webinar, I really appreciate you being here today, joining me for learning all these different concepts and overviews. Again, please contact us. We'd love to hear from you, and I wish you the great rest of your day.